Let's start with your presentation one, discussion of your presentation one. So this is your presentation one, layers of the Earth. Let me have it full screen like that. Now, if we go to next, um, the layers, there are two categories for determining the layers. One is through composition, so it's basically based off of chemical composition of the materials in the layers of the Earth. And the second one is about mechanical state, which is primarily based on the phase, so whether it's solid, liquid, gas, or something in between. And obviously, it's relative movement within the layers of the Earth. Okay, so let's start first with compositional layers. So compositional layers are three. I think this is common to you already: crust, mantle, and core. So the main difference is the composition. So the core is actually made up mostly of iron and nickel. So almost all of it is iron and nickel, while the mantle is made up of some iron, some magnesium, and silicates of them, right? And then the crust contains less of iron and nickel and magnesium, but more of what we call the silicate rocks. Okay, so these silicate rocks are primarily two kinds: granite or granite, and basalt or basalt. Basalt. I think both four pronunciations are correct. But the thing is, if you're in an ocean floor, what you can find is that basaltic rock or basalt. And then if you are in the um, land masses, then you would have a basalt layer, and then on top of that is granite. Okay? So, again, the crust is made up basically of a base um, rock layer, which is basalt in the ocean, and in land masses, basalt and then granite. Okay? But on top of that is what we usually see, which is the soil. So, soil class is basically a mixture of weathered pieces of rock, trapped air, water, biotic organic matter, such as probably animal dung, probably decayed leaves, um, bodies of insects that have died. That is what we call soil. I'm trying to emphasize this because you see, when we look at the land, the piece of solid material that we are standing in, we usually say soil. But the soil part of the crust is very, very thin. Below that, you still have basalt and granite, or granite and basalt rocks. Okay? In the ocean floor, you don't see soil, but you can see siltation. So it's similar to soil. It's just that it's not soil because it's not on the surface of the earth exposed to the atmosphere, but it's under water, so you have siltation. But the same thing, you still have organic material such as, again, um, maybe poop from fishes or decayed organic material. Okay, just to illustrate my point, if you have seen The Martian, in The Martian, um, you can see all of these dusty weathered pieces of rock on the surface, but you don't see soil. Why? Because soil is, again, primarily made up of organic decayed material, right? And in Mars there are no living things, at least not yet discovered. So we don't see that feature. If you notice in the movie, what did Matt Damon have to do? Was that Matt Damon, or I'm not sure. Parehas. But what did he do in order to plant um, the potatoes? He had to harvest the poop from the colony, the poop that the his fellow astronauts or explorers left before he was left behind, and he mixed it in with the crustal dusty material from Mars to create soil. Okay, so that's it. So again, from the top you see soil, and then you see granite, and then basalt. In the oceans, you would see siltation, and then below that is basaltic layer. Now the mantle, so if you can see the pattern here, it's like the core has the most iron and nickel. The mantle has some iron, but it's in the form of silicates, right? And then the crust has less of that, but more silicates. So if you notice the pattern, less, the least amount of silicates, more silicates, the most amount of silicates. But in terms of iron and nickel, most iron nickel, lesser iron nickel, and least amount of iron and nickel. It doesn't mean we don't have iron and nickel in the surface. In fact, if we don't have iron and nickel, then we could not build buildings, because all of the buildings that we have iron component in the um, backbone, in the foundation, mga kabilya nga atong gigamit, right? But that's the compositional layers. You have the crust, the mantle, and the core. By the way, a very interesting thing to note, the core is just 20% of the Earth's volume, but it contributes 37% of its mass. So, gamay nga volume, dako nga mass. So if you have a bigger mass but small volume, mass over volume, that's density. That means the core is the densest compositional layer. That's followed by the mantle, which is 68% of its mass is from the mantle. The volume is 80%. And the crust, therefore, is the lightest in terms of density of the three compositional layers. Okay, so again, compositional layers: crust, mantle, core. More silicates, least amount of iron and nickel. Uh, More silicates, more amount of iron and nickel. And then in the core, you have the most amount of iron nickel and the least amount of silicates. Okay, so that's the pattern. So um, uh, that would be the discussion for the compositional layers of the Earth. Okay, so